So this additional video covers the angular and linear speed formulas that we talked about in class. And so as we go through these problems, the goal is to be able to identify which formula to use and then actually figure out how to use that formula. So for problem number 16 here, we're just converting revolutions to radians. So if we have 4 revolutions, each one of those revolutions is 2 pi radians. So we use this formula up here, the big R equals theta over 2 pi. So if we want the radians, which are the theta, we can just take our 4 revolutions and multiply it by 2 pi, and we get 8 pi radians. And you could do that as a decimal form too. It's approximately 25.13. But revolutions to radians, just multiply by 4 pi. So same kind of thing in number 17, right below it, 56.56 revolutions. If we want to know how many radians that is, each one of those revolutions is 2 pi radians. So just multiply 54.56, multiply that by 2 pi. And I'll just give this one as the decimal, 342.81 radians. So each of those revolutions is 2 pi radians, so it's going to get have more radians than revolutions. But what if we go the other way? For number 18, we have radians and we want to get revolutions. So 7 pi over 6 radians, how many revolutions is that? Well, we can go back to that same formula up here. Revolutions equals theta over 2 pi. Well, now we have our theta. Just take this and divide it by 2 pi. So 7 pi over 6, divide that by 2 pi, which, if you're simplifying fractions, becomes 7 pi over 12 pi. The pi's cancel out. We're left with 7/12. If you go and just type that whole thing into your calculator, you would get, as a decimal, about 5.83 repeating revolutions. So then we get the 8 pi radians to revolution. So let's take 8 pi and divide it by 2 pi. So 8 pi radians is exactly 4 revolutions. So we just need to keep track of whether we multiply by 2 pi or divide by 2 pi to go between radians and revolutions. For number 20, we are given a windmill rotating in revolutions per minute, and we want to try and convert to an angular speed in radians per minute. We can keep the same time increment there since it doesn't specify. And then the linear speed, which is in feet per minute. Since the radius is in feet, we'll just keep those units the same. So to go from revolutions per minute to radians per minute, we just need to take our 12 revolutions per minute and multiply that by 2 pi, right? 2 pi radians is equal to 1 revolution, and so our revolutions will cancel. We have 12 times 2 pi. That gives us 24 pi radians per minute. Or if you prefer putting things in as a decimal, that's equivalent to about 75.4 radians per minute. So these are the angular speed in radians per minute. Now we want to convert this into a linear speed, which is feet per minute. Well, this goes back to our V equals R omega formula in that top row up here. That this V is our linear speed, which is what we're trying to find. And to find it, we need to take the radius times omega, which is the angular speed. So radius times angular speed. Well, we have the angular speed, the 24 pi. Let's just multiply that by our radius of 6. So 24 pi times 6 gives us 452.4 feet per minute. Now the units don't matter too much in this case because we didn't specify the units. But you should be able to convert this into inches per hour, miles per second, whatever it happens to be. So in 21, we have the same type of thing, a bike wheel radius of 8 inches, and it rotates at a speed of 2.5 revolutions per second. Again, we want angular speed and linear speed. So to go from revolutions per second to radians per second, we can just multiply by 2 pi. So 2 pi radians per 1 revolution. Those revolutions cancel out. We will be in radians per second. So 5 pi radians per second. If you like the decimal equivalent of that, we get 15.71. So there's the angular speed. But then to get the linear speed, going back to that formula V equals R omega, we need the radius times the angular speed. So take our angular speed, multiply it by the radius of 8 inches. And 5 pi times 8, 40 pi. But it might make a little more sense if we do this as 125.66. And now we're in inches per second. Since our original radius was in inches and our time was in seconds, we'll be in inches per second for that angular or that linear speed. So for the last one, we have a cylinder with a 2.5 foot radius, and it's rotating at 120 revolutions per minute. So we want to find that angular speed in radians per minute. But then we're going to do some other things in here. We're going to find the linear velocity in feet per minute and then convert that into miles per hour. So same type of calculations that we just did, but we're going to have that extra piece at the end of converting into miles per hour. So angular velocity in radians, so that's converting 120 revolutions per 1 minute into radians per minute, so 2 pi radians per 1 revolution. So that gives us 240 pi radians per minute, or again, if you'd like the decimal equivalent, 753.98 radians per minute. So there is your angular speed. Then we want the linear speed in feet per minute. So we go back to our V equals R omega. We know the radius is 2.5. We know the angular speed is the 240 pi. So let's take 240 pi, multiply it by that radius of 2.5. And in exact form, we get 600 pi feet per minute. But you might be having the decimal equivalent in there. So let's call this 1,884.96 about feet per minute. So now we want to convert that feet per minute into miles per hour. So we need to use our dimensional analysis. So I'm going to use the 600 pi just because I like accuracy, but you could use the 1884.96 if you'd like. So we have 600 pi feet per 1 minute. Now there's two conversions here. We need to get the feet into miles, and we need to get the minutes into hours. So to get feet into miles, we can multiply by our conversion factor of 1 mile is 5,280 feet. And I put the feet on the bottom so that they would cancel with the feet that are on the top. Now our answer is in miles per minute. Well, we don't want miles per minute, we want miles per hour. So we need to convert the minutes into hours. So let's multiply by the conversion factor. Minutes into hours is 60 minutes per 1 hour. So we moved feet into miles, we moved minutes into hours. So now just multiply across, we get 600 pi times 60 is 113,097.3355 divided by that 5,280 on the bottom. So divide by 5,280, and this becomes 21.42 miles per hour.